Welcome back for the fourth lecture of this week. So we started talking about information extraction, and there we discussed a particular problem of relation extraction, and we discussed one approach that is using handle patterns. So we can build some patterns manually, and we saw that by using that we can extract certain relations between entities, and there was some limitations with that. So we will now see some other approaches apart from hand-built patterns. So starting with the bootstrapping approaches. So we had talked about bootstrapping approaches in one of the earlier topic, that is on word sense disambiguation. But let us see how do we apply these approaches for the task of relation extraction. So here, so you will use these approaches only if you do not have a lot of annotated data, because if you have some annotations already available, then you can use some supervised approaches that might give you better results. But suppose you do not have annotated data, that means data where it is labeled entity 1 is related to entity 2 by a particular relation R. If you do not have such data, you will use a bootstrapping approach. So you do not have enough data, but what you have are some seed instances of the relation, and that is very easy. Okay, what do I mean by seed instances? So remember we were talking about hypernames or meronyms. So you know some seed relations. So you know, okay, basement and building are connected by the meronym relation. Car and vehicle are connected by the hypernym relation. So you know some seed instances. Okay, then what else do you need? Or you might have some patterns that you know, and lots of unannotated data. So that means you should have a lot of corpus where you have a lot of text data. It may be unannotated. It's a simple text data. So idea is using some seed patterns, running some idea over this whole data. You can try to bootstrap your approach for relation extraction. So the questions here are, so here you have some seed instances. So how do you use them for doing something meaningful, so that you can extract various other entities? So you have some seed instances. How do you use that for extracting more such examples? And so this can be considered some sort of a semi-supervised approach. So what do we do here? So let us take some simple example. So here, suppose my relation is burial place. So X is buried in place Y. I want to find out all such entities that are connected by this relation. So how do I go about it? Firstly, I need to see if I have some seed instances, that is some entity that are connected by this relation. So suppose I have an instance that is Mark Twain is, and the burial place is Elmira, New York. So I have this seed tuple. Now how do I start? So remember, what did we need? We need some seed instances and a lot of corpus data. So now you can use the intuition that how are you finding out the patterns in the case of handle patterns. So again we were starting with some seed instance, so like basement, building, and we were trying to go through the corpus and seeing wherever these two words occur, what is the pattern in which they occur. Same thing you can do here. So you know, okay, I have two entities, Elmira and Mark Twain. Now you can search your whole corpus to find out where all these two entities occur together in a single sentence or in some proximity. Now wherever they occur, you try to find out in what pattern do they connect to each other, and these patterns you can generalize as your generic patterns without having to manually go through each of these. So something like, so I have these entities Mark Twain and Elmira, and maybe I can Google this entities Mark Twain, Elmira together, and let us see what are the kind of sentences do I get. And suppose I get the sentences like this. Excuse me. Mark Twain is buried in Elmira, New York. This is the sentence, and I know what are my entities here. Mark Twain is X, Elmira is Y. So I can immediately form a pattern. X is buried in Y, and this becomes my pattern. The next sentence, the grave of Mark Twain is in Elmira. So I can have this pattern. The grave of X is in Y. Similarly, Elmira is Mark Twain's final resting place. So I have this pattern now. Y is X's final resting place, and so on. So you are getting these sentences. from this sentence you are abstracting over your entities x and y, and you are building patterns in terms of x and y. So what you saw here, just by using one seed instance and a lot of unannotated data, you can find out some patterns. Now once you have patterns, what you will do, you will use these patterns to find out more and more such entity pairs that are connected by this pattern, and that will enhance your seed tuples or seed instances. Then you can again use the seed instances to again search the corpus, find out more such patterns, and this can be done in an iterative manner until there is some convergence going on, or you are seeing that it is not helping much. So now you have these patterns and you use these to search for new tuples. So this can be described by this simple flow chart, that is, you are starting with this some sort of seed tuples like Mark II and Elmira, then you are searching this tuple in the corpus and you are finding various patterns, and this becomes your pattern set. You might also have some seed patterns already, but you are getting some patterns now. Now using these patterns, you are searching the corpus and finding more tuples and putting them in your relational table, and that is going to your tuple set. Now using your tuple set, you can search these and find out more patterns, and this can keep on going in many iterations. And this is a very nice approach. You can see that you only need data that is freely available everywhere, and you need some very few seed instances, and you can apply this algorithm. And this does not require to do everything manually. So yes, but there are some problems with that approach. The problems, for example, are that the seed instance with which you start should be a good instance, such that there are many occurrences of this seed in the corpus. If the seed pair does not occur in the corpus, you will not be able to extract many relations, many patterns from this. So this is one problem with this approach. So this is sensitive to the original set of seeds that you use for your algorithm. And in general, there can be many parameters to tune. For example, how many top patterns will I take from my set, how many iterations I will go through, and how many times I will send the same pattern for search. There can be many parameters that you have to fix. And yeah, there is no such probabilistic interpretation, so it's difficult to know how confident you are in each pattern or each tuple that you are finding by this approach. So these are some sort of problems with this approach, but it's a nice approach if you just want to get it done without building some sort of machine learning method also. So you can use this approach for some simple and easy results. But we will see if you want to build a more robust system, that what kind of approaches you can use. So for that, we can talk about some supervised approaches for relation extraction. So what is the idea? So first you will define what are the kind of relations you want to extract. So relations can be many, like, okay, I want to extract family relations, so parent of, wife of, husband of, and so on. You can extract some organization relation. This is an employee of and subsidiary of, and so on. So we'll define a set of relations. Now, for each relation, you'll find data and label the data. So there should be some manual labeling involved. Somebody has to label the data that, okay, in this sentence, these entities are connected by this relation. So you will choose a representative corpus where you think that there can be some instances of this relation. Now you will label the named entities in the corpus and hand label the relations between the entities. So what will happen? You have a corpus, you will find out sentence S1, S2, S3, S4, and you say in this sentence there is entity 1, there is entity 2, and you know what is the relation between them. Similarly here you will find, okay, there is one entity 1 prime, entity 2 prime, and there is some relation prime here, and this has to be hand labeled. Why do you need hand labeling? So once you have these hand labels, they are like your so this is like your gold standard that you can use as your training as well as testing data. So you will train your system using, okay, in this sentence, if these are the entities, this is the relation between them. So in a new sentence, suppose two entities are there, is there relation rel between them. So this can be some machine learning model that you can build by using this gold standard. And then you will break into training, development and test. That is the usual practice in machine learning. And then you will train a classifier on the training side. So now, so here might be one problem while you are using this approach. In general, there can be hundreds of relations, and so you need to so when you are given a sentence between two entities, there can be many relations, but there may not be any relation at all. It might happen that two entities are occurring in a sentence, but they are not connected by any relation in your repository. So there is no relation as such. So what you might do is to have the first step that says, okay, in a sentence I know what are all the entities, and this first step tells me which two entities are connected and which two are not connected. And once you have the output of this step, you know these two entities are connected, then you run your additional classifier to find out what is the relation between them among all the hundreds of relations that you have. So this is seen to be working in this area of relation extraction. That first you find out what entities are connected, second what is the relation between them. So it's a two-stage approach. So you find all pairs of entities in a sentence, and the extra step can be build a simple binary classifier. So that it says yes or no, and it decides whether two entities are related or not. And if you find an answer yes to this step, use another classifier to find out what is the relation between these two entities. And why will that help? Because in the first step itself, you will be able to eliminate a lot of extra pairs that are not involved in any relation. So you will not bother about those. You will only bother about those entities that are probably connected by some relation. Other advantage could be you can think of various sort of features that you will use for the first step, that is finding out if there is a relation or not, and the second step, that is if there is a relation, what is that relation. You can think of various set of features that you can employ for both of these steps. So here is one visualization of what this will look like. So suppose you have this sentence: American Airlines, a unit of AMR, immediately matched the move, spokesman Tim Wagner said. Okay. So now suppose by using the first step you found out that American Airlines and Tim Wagner are connected by a relation. Okay. So now you want to find out what is the relation. So here you have the sentence, two entities, and you need to find out what is the relation among all these possibilities. It's a family relation, citizen relation, subsidiary relation, founder relation, and so on. So a lot of relations are there. You want to find out what is the relation between these two entities. Now how do you solve this problem? How would you solve this problem? So you will have a lot of label data where you know these are the entities here and this is the relation between them. So in classification, what we do, from this label data we try to abstract over some sort of features. So we say, okay, so these are the features that I see in this sentence, and these features indicate relation 1. Other sentence I am seeing these kind of features that are indicating relation 2, and so on. So this is what I'll have from my training data. Now at test data, again I'll try to find out what are the features, and using these features I'll try to match with one of these previous examples I have seen in training data. This is a simple illustration, but it is generally more complex than that. But this is the basic idea. So the whole effort goes in deciding what should be my ideal features by which I can represent all my data points. So how do I say, okay, these two are connected by this relation? What are the different things in the surrounding, in the context about these entities that I should be using to make this decision? And that is your task of feature engineering. Find out what are the features that will help you in this task. In most of the NLP application, this is one of the main challenge, that for this task, find out what are the appropriate set of features I can use. So we will see some examples that so here you can use all the different concepts that are covered in this course. So starting from simple language models, part of speech tags, dependency paths, syntactic paths, everything you can use to define what are your features in this task. And we will see a lot of examples here. And this is one. So if you want to build your own systems, you might have to start thinking in terms of what are the important insights from data that I should use as in the form of my features. So remember, features are something that you think can help me discriminate between various relations here. So it can help me tell if this is a family relation versus if it is a citizen relation. What are the different things that can help? Are these various words that occur in the context? Are these a part of speech tags? And or is there something else? So this you can abstract in terms of your features. So let us see what are the kind of features we can use for this task. So I have the sentence, American Airlines, etc. And my initial features could be, what are the words in my mention M1 and M2. So M1 is American Airlines, M2 is Tim Wagner. So what are the words that are used in these two mentions? So features here can be bag of words features. So mention 1 uses words like American and Airlines, and mention 2 uses words like Tim and Wagner. So these are simple features. I can also use what are the head words of these two mentions. So head word mention of mention 1 is Airlines, and for the mention 2 it is Wagner. And you can also see what is the head word mention of 1 plus 2, Airlines plus Wagner. So why you are using this head word kind of features? So here you are having American Airlines, but suppose there is something like Indian Airlines or some other airlines. So by using the head words, you can capture even a new word that has the same head word, but the initial word was different. That can be captured by using head words. Same with Tim Wagner. So you are capturing the surname here by head word, but suppose someone else has a surname Wagner, so it can also be used. Then I can use what are the words that are coming around the mentions. So that is, what are the words that are coming before American Airlines, after Tim Wagner, and what are the words in between. So what can be my features? So words or bigrams in particular positions left or right of M1, M2. Like, what is the word before M2? So spokesman. What is the word next to M2? That is said. Okay. So what you are abstracting here, I have an entity before which I have a word spokesman, and next word is said. So in a new context, whenever I see word spokesman before, word said afterwards, it might indicate that there might be this relation. Okay, spokesman X said. It might be a good indicator of this relation. You can also use the bag of words or bigrams between the two entities. That is, what are the different kind of words that occur between the two entities here. So you will say, okay, so words like AMR, immediately, matched, spokesman, unit, etc. They are all occurring between the two entities, and they all go as your features. So you can have name entity type and mention type features. So for example, what is the name entity tag for the mention one? So this is an American Airlines is an organization. So this you can get by using various name entity recognition tools. You can run an NER and you can find out what are the various name entities. So you say, okay, mention 1 is in organization. Similarly, mention 2 is a person. So this can be nice feature that can help you. This is in organization, this is in person. So what can be a relation between them? And yeah, it can be together also. What is the name entity for 1 and 2 together? Organization, person. Then you can also find out entity labels of mention. This is a name, nominal or pronoun. So here first one is a name, second one is also a name. But suppose in the sentence you have it, he, etc. So you can call it as a pronoun. On the other hand, if you have a word like the company, you will call it as a nominal. So all these can also be your features. Now suppose you want to use the dependency between them. So you will see when you convert the sentence to a dependency graph, what is the connection between the two entities? What are the different branches in the tree by which they are connected? So suppose you find this dependency graph, so you will see, okay, so they are connected by this path, matched, said, and you are seeing going to Wagner. Airlines, matched, said, Wagner. So now you will try to use certain features based on this path also. Okay, so it can be maybe what are the words that are occurring in this path, or what is the complete path altogether. So here, what is the head word of the dependency head word for word 1. So you had airlines, matched airlines. This is the dependency for the word 1. for head word 2, so you have the dependency Said and Wagner. So this can be a feature, immediate dependency feature, matched airlines Said Wagner. Then what is the path? Airlines matched Said Wagner. And you can also think of some other features. Okay, what is the label they are at in that dependency graph, how many different words they are connected to, and so on. And then you can also do chunking and use features like, okay, if you chunk them, you will find American Airlines, A unit, off, AMR, etc. And your feature could be what is the chunk in which it participates, what is the next chunk after this, and so on. You can also use the constituency pass features. So you have the two words here, American Airlines and Tim Wagner, and this is the parse tree of the sentence. So you can use the path from here for the noun phrase to this particular noun phrase that connects Tim Wagner. So what is the path? You are going to a noun phrase, to a sentence, to a sentence, to a noun phrase. This path can be helpful. Again, here you can use what is the label in the tree they are at, and what is the sibling, and so on. So these can be your various features. Then there can be some sort of features that you can obtain from various gadgetiers and different terms, kinship terms. So if your relations contain mother of and parents of and all that, so you can use some kinship terms. So like parent, wife, husband, grandparent, etc. And these can be obtained from various lexical resources like WordNet also. And then you can use various gadgetiers like what are the country name list. So you can see, okay, so the next word after the entity 1 is the name of a country, or the previous word after the entity 2 is the name of a country. Similarly, for names of very famous celebrities or persons, all these can be used as your features. So this is the idea that you have this task, you have to find out the relations, and you should be able to use whatever sort of features you think will help in this task. So you are seeing we are using a lot of different sort of features, and there you are using all the different concepts and topics that you have seen in the basics of this course. So you can have country name list, other subentries, etc. So now, once you have identified what are your features, so what will happen in your training data, each instance you can convert in a feature vector. So we know what are the different features that are involved in this particular sentence. And then you can use various classifiers to build to find out, given a new sentence, how do I find out if the two entities have a relation and what is the relation. And then you can use multiple classifiers like knife Bayes classifier or SVM or Maxent, etc. And this is the rule always: you train on the training set, tune on the development set, and test on the test set. So you should never use your test set for building your features or whatever patterns. So you should never use the test set. It should be kept separate. So you will only tune on your development set. If you have a training set, you run your classifier and initially test on the development set. If it doesn't work, keep on improving, and once you are satisfied, then run it on the test set and find the accuracy. And you might also have to compare with others if you want to find out if you are doing something better than what people have already done. So now how do I, so once you have done this classifier, you will get your, so classifier will tag in this sentence these two entities are connected by this relation and so on. Now how do you find out how good your system is performing, and how do you compare it with other systems? So for that, we need to talk about what are the various evaluation measures or evaluation metrics. How do I evaluate it? Okay. So standard evaluation metrics are: what is the precision, what is the recall, and what is the F measure. So how do I define these? What is the precision, recall, etc. So here are the simple definitions. So precision is, so for suppose I am doing it for each relation separately. So precision would be what are the number of correctly classified or extracted relations divided by total number of extracted relations. So that is, suppose my system is giving, okay, so these entities, these pair of entities are connected by a relation R. Okay, this is the output of my system. Now from a gold standard, suppose I know that this, and this is correct and this is incorrect. System gave 4 output, 3 are correct. So my precision here will be 3/4. So this is one very important metric, that my system should have a high precision. It should be, whatever relation it is predicting should be correct. What is the other criteria? So other criteria is recall. Recall is what are the number of correctly extracted relations that my system identified divided by total number of gold relations. Now it's important to see the distinction between the two. So what we will do in the recall, so the system output. In recall, I will see what are the gold standard relations. Suppose in my gold standard, I had 5 entities. I know these entities are connected by this relation. And suppose my system has found out, so it has found out 3, it has found out this, this and this. But my system could not find out this and this. So what is the recall of my system? My system could recall 3 out of 5 possible relations. So recall here would be 3/5. Okay, and this I can do for every relation independently, and I can show my system does work for this relation with this precision, this recall, and so on. Now there is also a metric where you can combine these two, and that is called F measure. And what you do is to take some sort of harmonic mean. So this is 2PR divided by P plus R. You will take a harmonic mean of precision recall, and that is called your F measure. So this is F measure, 2PR divided by P plus R. Although there are variations where you can give different weights to precision and recall also, but this is quite accepted measure, that you give equal weightage to precision recall and find out an F1 measure. So now if we try to summarize the supervised relation extraction task, what we did here. So in general it can achieve very high accuracy for some relations, and if we have lots of hand labeled training data. So for most of the machine learning algorithms, they all depend on how much labeled data that you have. So if you have lots and lots of data, they can give you better and better accuracy. So that is one bottleneck also. So you need to label lot of data to be able to get good accuracy. And yeah, so this is the limitations here. So labeling large training set and the entities might be very, very expensive, and it may not generalize to different relations. So I have labeled for some relations, but suppose I want to now extract some new relation, I cannot use these labels. I need to get new labels for the new relation. So whatever I have labeled, the model will only be able to extract those relations. A new relation, I have to do the labeling again. So this also does not generalize. So we saw two approaches in this lecture. We saw bootstrapping. You do not want to annotate a lot of data. You have some seed instance, you go for that. But you can, if you can annotate a lot of data, then you can use the supervised approaches. And there the main problem is after labeling, find out interesting features that can help with this task. Now in the final lecture for this week, we will see an interesting approach that blends these two approaches together, bootstrapping and supervised approach, and this can also generalize to many different relations that you have. So this approach is called distance supervision. So in the next lecture we will talk about that approach.